Hello! Today we are going to talk about functions. Functions are actually something you talked about at the beginning of the year with Mrs. Jensen when I was not here, but she was teaching you guys. So, what you're going to learn or hear about today might sound familiar. If so, excellent. If it does not, that's totally fine. That's kind of why we're talking about it again today. So, everything we talk about today, you also learned about at the beginning of the school year, which was a long time ago. Then tomorrow, I'm going to teach you something new about functions. So let's go ahead and get started. A function is a relationship, some kind of graph, table, or equation, where each input has one output. This means each x value has only one y value. So each question has only one answer. Or each time you plug in x, there's only one possible answer for it. But be careful because y values can have different x values. And I'm going to talk about what I mean by that in a couple of minutes. So when we talk about functions, we always have some kind of input. That's kind of the number we're putting in. We also can call that the domain or the x value is kind of what we call it in class. And then we always get some kind of answer, which we call the output or the range or the y value. And sometimes when we have a function, people think of it as this process as a function machine. You put some kind of value in, your x value in, and you get some answer y, or your output y. So for example, if I have this as my function machine, I have the rule y equals 2x plus 1. Well, all this vocabulary of saying function machine, the process is still exactly what you already know how to do. Let's say I put in the number 3 into my machine. Well, all that really means is I'm plugging in the number 3. So 2 times 3 is 6 plus 1 is 7. So my input was 3 and my output is 7. Or my x value is 3, my y value is 7. We could also write that as a coordinate point, 3, 7. That works out great. What if I have an input of -1, or my domain or my x value is -1? Well, then I put in a -1 and I'm just plugging in. 2 times -1 is -2, plus 1 is -1. So my output is -1. Now notice that this number and this number is the same. That's totally fine. So I could also write it as -1, -1. What about the number 0? Let's say I plug in my 0, or my input is 0. 2 times 0 is 0, plus 1 equals 1. And I could write that also as a coordinate point, 0, 1. So sometimes when we have a function, it'll show us something like this, where this, or our x values are on one side and we have an arrow being drawn to the answers on the other side. Cool, awesome. What's important, how we know that this is a function or is not a function, is that the numbers in the x side only have one arrow pointing away. So this 3 does not also point to something over here. That's a no-no. But because they each only have one arrow pointing away, that's fine. Sometimes you'll see functions written like this as just a list of coordinate points. The thing that tells you if it is or is not a function is that the x value does not repeat. So this number 3, you don't also see a number 3 here. You don't also see a number 3 here. Now, we only look at the x values, though. The y value doesn't matter. This could be a 7, and this could be a 7, and this could be a 7. That's fine. What matters is that the x values do not repeat. So x value does not repeat. So let's take a look at this next one. Let's say we do x is 5. If I plug in a 5, the rule here is that y is 7. So if I plug in a 5, I don't have to do any math. I don't have to use my calculator. I can just know the answer is 7. Let's say I plug in a -4. Well, it doesn't matter what x is, the answer is still 7. Let's say I plug in a 28. It doesn't matter what the x value is, the answer is still 7. So if I had a picture, it would look something like this. This is okay. So this is what I said earlier where I said be careful because the y value can have multiple x values. Well, this y value of 7 has a whole lot of x values. That's totally fine. This is yes, okay. What this would look like as coordinate points would be 5, 7, -4, 7, and 28, 7 with our little fancy brackets around it. And again, when we look at this to know if it is a function, as long as these x values do not repeat, then we're fine. As long as the x values are different, we are happy. The y values being the same, doesn't matter. Okay, let's take a look at our next rule. Our next rule is x equals -2. This means that x is always -2. So the only thing I'm allowed to plug in is a -2. I can spit out a whole bunch of stuff. This tells me nothing about y. This means as long as I plug in a -2, I can get whatever I want, right? I'm going to randomly choose. I could choose 5, I could choose 8, I could choose -21, I could choose 0, I could choose, whatever. What this would look like is I put in this -2 and I get out a whole bunch of different options. This is not okay. So it's actually the opposite of what we had here. Notice here, it was the y value that was, it had a whole bunch of things pointing to that thing. Well, here it's just the opposite. The x value has a whole bunch of lines. That is not acceptable for a function. So we can't call this a function. Although it's a thing, it's not a function. What this would look like as a point, or as a set of points, is -2, 5, -2, 8, -2, -21, and -2, 0 with the little fancy brackets. And we always look at the x values. It's good if the x values are all different, but here the x values are all the same, so this is not a function.